Hey everyone, how are you doing? I am going to do a video today to get you started on the 5.4 to 5.8 worksheet. I'm going to do problems 1, 7, and 17, which will hopefully get you going for the rest of the worksheet. Starting with problem number 1, 5x plus 2y equals negative 8. Remember last week I said you can't really solve this. The directions say write the slope-intercept form. So what that means is rearrange it so it looks like y equals mx plus b form so that it can be graphed. Okay, this is in standard form, well, that's what we call it, and I want the y to be in the front, so I'm going to get rid of this 5x first. Minus 5x from both sides. And I have 2y equals, okay, so remember from last week, the x part needs to go in the front, and then the constant. Negative 5x goes in the front, and then minus 8. Notice it's negative 5x because that was subtraction, and minus 8 because that was negative. Okay, so I'm almost done. I almost have it looking like this. It's just 2y instead of y. So I need to divide by 2 on all three terms. The 2's cancel in the front, and I have y equals negative 5 over 2x. This can't be reduced, but this can. Negative 8 over 2 is negative 4. Okay, so if I asked you to graph this problem, it would have a y-intercept of negative 4, so you'd go down 4 on the y-axis, and then you would go down 5 boxes and right 2. You don't have to graph these, but that's the purpose of this, is to get it into a form that's easier to graph. Okay, now number 7, same directions, it's just set up a little bit differently. Y plus 5 equals negative 1/2 x minus 5. Okay, so this is called point slope form, and what we need to do is rearrange it again so it looks like this. When you see parentheses, typically you want to distribute first. Y plus 5 equals negative 1/2 x plus, okay, I have a fraction times a number, so first thing to notice is that I have a negative times a negative, which is a positive, and this is technically 5 over 1. So you want to multiply the numerators. 1 times 5 is 5, and multiply the denominators. 2 times 1 is 2. If you really want to, you could make this 2.5, but I prefer you keep it as a fraction, especially because I think that will match the answers on for the worksheet. Okay, so minus 5 from both sides. Y equals negative 1/2 x. Okay, so I'm going to get the calculator out for this. Some of you guys might not have a calculator at home. I know a bunch of you know how to do calculations on either the internet or gasp your phone. So I have 5 over 2. Remember the over button's right here if you do have a calculator at home. Minus 5, and that's negative 2.5. Okay, and this is fine, especially because if you're graphing, it's easier to see where 2.5 is. If you want to leave it in an improper fraction, remember we go second fraction button, and that would be minus 5/2. So I'm just going to write or y equals negative 1/2 x minus 5 over 2. And I'm sure a few of you have negative 2.5 there, which isn't my favorite, but that's okay. Okay, now to number 17. The directions here say solve each system by graphing. This set of directions is new to us, but this type of problem is not. So what I need to do is explain to you what it's doing and what it's asking. So I have y equals 3x plus 1 and y equals negative x minus 3. Okay, this is called a system of equations. It means that there are two of them and they both have the same variables. This one, they both have x's and they both have y's. This system in particular, and a lot of the systems that we'll work with, have one specific x and one specific y that will work in both of them. That's called the solution. So y might be 5 and x might be 2, which would make a true statement in the top and a true statement in the bottom. This particular set of equations, or set of directions, says solve each system by graphing. So we are going to use what we already know about graphing to find that solution. Okay, so starting with the first equation, y equals 3x plus 1, I'm going to go up 1, and then 3 is a whole number, so I'm going to go up 3, right 1, and then you know me, I like to backtrack a little. And my straight edge was just here. It really was. Oh no. Oh, here it is. Okay. Okay, now the other one. Okay, so negative 3, go down 3 on the y-axis. Notice I'm graphing it on the same graph because what I want to do is find the solution to the system. I want to find the solution to these equations together. What set of x and y works for both? And the slope here, if you guys remember, if it's negative x, it's negative 1, we put a 1 there, and then that's a whole number. So we have negative 1 over 1, which means we go down 1, right 1. Great. I bet you guys can tell what the solution is. The solution is the coordinate where the two lines cross each other, which is right here. So our solution is this point, which is negative 1, negative 2, which is where they cross. Okay, now this is not required in each problem. This part is done. That's the answer. But what I want to do, because this is our first system, I want to prove to you that this is the correct answer. So what I'm going to do is plug negative 1 in for x and negative 2 in for y in both of these and show you that it works in both. So negative 2 equals 3 times negative 1 plus 1. Negative 2 equals negative 3 plus 1. Negative 2 equals negative 2. Check. Okay, now I'm going to plug it in the second one. Negative 2 equals negative 1 minus 3. Notice I have the negative and then x. Negative 2 equals 1 minus 3. Negative 2 equals negative 2. Check. So there's my check to show you that the solution x equaling -1 and y equaling -2 is the one set of one ordered pair that will work for this answer, and that is where the lines cross. Okay, you guys, so luckily you know how to do all of this graphing. All you need to do is be very careful and find where the lines cross, and that will be your x and y solution. Talk to you guys soon. I hope you're having a great week, and let us know if you need anything. Thanks. Bye.